In our previous video, we described the importance of phosphorus and the phosphorus crisis. Now that we know phosphorus is important for all living organisms, a new question comes to mind. How does phosphorus cycle throughout the environment? As stewards of this earth, it is important that we protect the planet and its precious ecosystems. This comes through understanding the science behind phosphorus cycling and ways we can mitigate the negative impacts of phosphorus use and efficiency. When it comes to the phosphorus cycle, we must make two important considerations. One, the biogeochemical aspects, or how phosphorus cycles through the environment, and two, the anthropomorphic aspects, or how human activities have impacted phosphorus cycling. Throughout this video, I will be referring to phosphorus and PhosFATE. Phosphorus is the pure elemental form as found on the periodic table, and PhosFATE is how phosphorus is commonly found in the environment, bound to oxygen molecules. PhosFATE is cycled throughout the environment through a series of exchanges between living and non-living factors. These exchanges mostly occur on land and in the ocean rather than the atmosphere. Of the phosphate that is in the atmosphere, it is found in dust particles and volcanic aerosols. Phosphate is present in magmatic and sedimentary rock and is freed from these rocks through a process known as weathering. Weathering is the slow process of deterioration when the rocks are exposed to water, wind, and other physical, chemical, or biological factors. This process takes over thousands of years to occur. Weathered phosphates dissolve in water, enter into streams and rivers, and then, ultimately, the ocean. Dissolved phosphates will condense and form deposits over the course of thousands of years. These phosphate deposits grow over time and can become accessible on land through a process known as geological uplift. In fact, this is how the phosphate reserves that we mine from came to be made thousands of years ago. Knowing this, let us consider this cycle with the addition of living organisms, starting with aquatic ones. When phosphate dissolves in water, marine organisms like bacteria and algae accumulate and grow. These organisms serve as food for larger and even larger organisms. Aquatic plants also accumulate these nutrients, providing food for terrestrial organisms too. Waste generated from these animals or from the remains of terrestrial organisms are rich in phosphate. This provides nutrients for plants or can return to the watersheds when it rains. In summary, weathering of rock allows phosphates to enter into the watersheds and oceans. Organisms acquire these nutrients, and these nutrients are returned through secretions or dead bodies of these organisms. Buildup of these sediments over a long period of time allow this process to start all over again. Now, how do we as humans influence this cycle? Since phosphorus is important for plant growth, we mine phosphate from these deposits and reserves to create fertilizers to apply to farmland. In fact, over 90% of the phosphate we use in agriculture comes from these mineable deposits. While fertilizer is helpful for food production, large amounts of phosphate can leach into the watersheds through rainwater runoff. Excess phosphate provides extra food for algae and causes them to grow at a rapid rate. This is problematic when these organisms die. Large amounts of oxygen are depleted from the water as they break down, and this causes the death of aquatic organisms. Areas of oceans or watersheds with low levels of oxygen are known as dead zones, as the oxygen levels are too low to support the life of aquatic organisms. Dead zones are found in the coastal areas all over the globe, the biggest being located in the Gulf of Oman, in the Arabian Sea spanning over 63,700 miles. This is not only limited to oceans. For example, the Great Lakes in the United States also have dead zones. The main causes of dead zones are from excess nutrient runoff from fertilizers, as well as when sewage, stormwater, and other industrial chemicals are released into the water. Overall, the human influence on the phosphorus cycle can have harmful environmental consequences. What can we, as humans, do to manage and prevent them? In the United States, the Environmental Protection Agency, or EPA, has established a list of preventative measures known as Best Management Practices, or BMPs. BMPs are the way that we can help farmers and municipalities manage nutrient runoff to protect the environment. We will discuss the specifics of BMPs in further detail in a future video.